breathless, rapid fire. Okay, so listen. You build these open weight giants, right? Like gpt-oss-120b and a leaner 20b, but they're out there, Apache license, yeah? They just hum with mixture of experts, sparse but sharp, like 100 specialists ready, but only 4 jump in at a time, super efficient. And get this, the kicker. You quantize them with this thing, MXFP4, just 4.25 bits per weight. Think about it, 120 billion parameters on a single 80 GB GPU. Suddenly, the impossible just feels light, and you teach them to reason in layers, low, medium, high effort. The chain of thought, it just unfurls, longer, sharper, exactly as you need it. No one size fits all, no. They adapt, they stretch, or they trim their effort. AIM math problems, bang, 97.9% with tools. Those tough GPQA, PhD questions, 80.1% and still climbing. And you craft harmony, this whole chat format with rules. System instructions beat developer, which beats user, a clear hierarchy it holds. Channels split the thinking from the doing analysis for the thoughts, commentary for tool use, final for the answer, and tools just. They bend to the model's will. Browse code, call any custom function like zero friction. Then there's the safety. You test it with fire, serious adversarial fine-tuning, biological risk, cyber exploits. They never breach that high capability bar. The safety advisory group, the SAG, they review, they confirm, even weaponize, they stay in line. Open, yes, but guarded. A balance nobody thought was possible. And you measure their reach. 14 languages on MMMLU, average 81.3% health bench. They get close to O3, actually outpaced GPT-4 where it really counts. Not doctors, no, but a bridge for global health's huge gaps, cost and privacy solved. Finally, AI's benefits spread wider. You watch them transfer skills, coding, tool use, that multilingual grit, the smaller 20B one. Still outperforms, punches way above its weight. Safety benchmarks, stands right there with O4 Mini, sometimes even better, jailbreaks. Strong reject holds, they just refuse to break. You step back, you look, and you realize you didn't just release models, you built a foundation. Open, adaptable, safe. A bridge between raw power and using it responsibly, yeah. Between closed walls and the community's collective smarts. This isn't just code, it's the next chapter of OpenAI's story, otherwise the system will crush. Takes a breath, slightly calmer. Whoa, okay, let's unpack all that. If that sounded like some urgent dispatch straight from the bleeding edge of AI research, well, that's because it absolutely is. Welcome to the deep dive. This is where we take that pile of sources you've seen and turn it into pure distilled insight, cutting through the jargon so you know what really matters. Today, we are diving headfirst into OpenAI's newest open weight giants, the gpt-oss-120b and gpt-oss-20b models. Our mission today, go beyond the buzzwords. We want to explore the really groundbreaking innovations packed into these models. Why should you care? Why does this matter for anyone curious about where AI is headed? And crucially, how is OpenAI tackling the unique safety challenges that come with opening up technology this powerful?
Yeah, and what's so fascinating here isn't just the raw power, the big numbers. It's the really thoughtful engineering that went into making these models both accessible and responsibly deployed. That's the tricky part.
Yeah.
So today, we'll peel back the layers on the technical ingenuity, how they got these massive models running on surprisingly small hardware. We'll look at how they learned to reason with this amazing flexibility and really examine the extensive safety measures that underpin this whole release, which, it raises a big question for all of us. What does open truly mean when you're talking about the absolute cutting edge of AI? The birth of the giants, architecture and accessibility.
All right, first things first, let's pull back the curtain on the models themselves. gpt-oss-120b and gpt-oss-20b. These aren't just new version numbers. They feel like a pretty significant step, both technically and maybe philosophically, in openweight AI. But maybe we should start basic. What does openweight actually mean in this context, and what's the core architecture making these things tick?
Good place to start. So openweight fundamentally means that the core parameters, think of that as the learned knowledge inside the AI, are publicly released. In this case, under a pretty permissive Apache 2.0 license. And this isn't just a technical footnote. It's a real commitment to transparency, and maybe more importantly, to customizability. It means researchers, developers, even, enthusiasts can actually look inside, modify them, build on top of them. It fosters innovation in a way closed proprietary models just can't, really.
Right, so it opens the black box a bit.
Exactly.
Yeah.
Now, architecturally, these are autoregressive mixture of experts transformers, MOE for short.
MOE, okay.
Yeah. The easiest way to think about MOE is like having a big team of highly specialized experts inside the AI. For the 120B model, there are 128 of these experts. But here's the clever part. When the model processes information, like a word or a phrase, what we call a token, it doesn't use all 128 experts.
Oh, okay.
Instead, there's an intelligent routing mechanism that picks only the best few experts for that specific token. In this case, it's the top 4 most relevant experts.
Only 4 out of 128.
Only 4 active per token. This selective activation, this sparsity, makes them incredibly efficient. They can have this massive total parameter, count the 120 billion, but still be performant and, crucially, resource-friendly when you're actually running them during inference. It's like having a giant library, but you only pull out the 4 specific books you need for your question instead of reading the whole library every single time.
Okay, that makes sense. Now, here's where it gets really interesting for anyone thinking about actually using these things, maybe outside a huge research lab. The sources mention this quantization thing with a funky name, MXFP4. Sounds super technical, but the buzz is it's a game changer for accessibility, right? What does that mean practically?
Precisely. Quantization generally is like finding a way to pack that massive library we just talked about into a much smaller box, but without losing too many of the important books. MXFP4 is the specific highly optimized compression format they developed for those mixture of experts' weights. It means those weights are compressed incredibly tightly down to just 4.25 bits per parameter on average. Now, why does this little technical detail matter so much? It has a massive practical benefit.
Okay, lay on me.
That colossal 120 billion parameter model, it can fit and run efficiently on a single 80 GBE GPU.
Wow, a single card.
A single card.
That's it.
And the smaller, but still very capable, 20 billion parameter one. That can run on systems with as little as 16 GBB of memory. Think standard consumer GPUs or even some high-end laptops.
That is huge. That really lowers the barrier to entry, doesn't it?
It dramatically lowers it. Imagine a small startup, an independent researcher, a university lab, maybe without a massive budget for compute. Suddenly, they can experiment and innovate with truly state-of-the-art AI at a scale that was previously just reserved for, tech giants with enormous data centers.
Right.
It really democratizes access to these powerful tools. It could unleash a wave of creativity, new applications, localized solutions that we probably can't even imagine yet.
So what this all boils down to for you listening right now is that these aren't just theoretical papers or models locked away somewhere. They're designed to be run by you, by developers, by researchers, pretty much anywhere. And that opens up a whole world of possibilities, especially for these agentic workflows, where the AI takes multiple steps, uses tools, also for strong instruction following, which we should definitely get into next.
Absolutely. And 2 other quick technical points worth mentioning. They also have a really long context length, 131,072 tokens. They use a technique called yarn to achieve this.
Whoa, 131K tokens. That's massive.
It is. It means they can process incredibly long inputs. Think entire books, long code bases, detailed conversations all in one go. And they use a specialized tokenizer called O200 Harmony. A tokenizer breaks down language into pieces the AI understands. This one is custom built for their Harmony chat format, ensuring the AI perfectly understands the structured commands and roles within that system. Which brings us nicely to 2, the art of communication, reasoning, chat formats, and tools.
Okay, yeah, perfect transition. We know they're accessible, but how do they think and talk? The sources mention chain of thought, this Harmony chat format, and variable effort reasoning. It sounds like OpenAI really focused on refining how you actually interact with them to get what you need.
They really did. A lot of this comes down to the post-training phase. They use techniques similar to their closed models, like O3, involving chain of thought, or CoT, reinforcement learning.
OT, right. The step-by-step thinking.
Yeah, exactly. The sources say this gives them a personality similar to models served in our first-party products like ChatGPT. What that means practically is they learn to show they're working. They lay out the logical steps they took to get to an answer. And this is incredibly useful, especially for complex stuff like math problems. It's not just about the final answer. Seeing the reasoning is key, like the smaller 20B model. It can generate over 20,000 code tokens just to solve a single complex AA math problem. That shows a real depth of reasoning for its size.
20,000 tokens for one problem.
Wow. Okay, and this Harmony chat format, it sounds almost like a mini programming language for talking to the AI with channels in this hierarchy. How does that actually work? What's the benefit?
It's a very structured approach, yeah. It uses special tokens to define roles.
Yep.
System, developer, user, assistant. The crucial part is that clear instruction hierarchy.
System over developer, developer over user. Exactly. System messages have the highest priority. They override developer messages, which in turn override user messages. What this means is a developer can set really powerful overarching rules or instructions, maybe safety guardrails, or specific persona instructions that a regular user can't simply override with their prompt. It gives developers much more control over the model's behavior.
Okay, I see. That sounds powerful for building reliable applications. And the channels.
Right. The channels add another layer of control. There are specific channels like analysis for outputting that chain of thought reasoning, commentary for when the model calls external tools, and final for the actual answer you want the user to see. This allows for really advanced agentic features. Imagine an AI assistant that doesn't just spit out an answer, but can actually interleave its thought process with calls to external tools, showing you exactly what it's doing and thinking at each step. It gives developers this incredibly granular control over both the internal workings and the outward presentation.
That is pretty cool. Very transparent. And variable effort reasoning. I love the sound of that. So you can literally tell it, like, think harder or, nah, just give me the quick version.
That's essentially it. You can configure the reasoning level, low, medium, or high, directly in the system prompt when you set up the interaction.
And higher means more accurate but slower.
Generally, yes. Higher levels usually mean longer, more detailed chain of thought processes. This often leads to better accuracy, especially for complex reasoning tasks. But the trade-off is increased latency. It takes longer to get the response and potentially higher computational cost to generate all that thought. So this feature puts you, the user or developer, in control of that balance. Need a quick draft? Use low. Solving a really tricky math proof or debugging complex code? Crank it up to high. It's all about adaptability for this specific task.
Love that flexibility. And these models aren't just thinkers and talkers, they're doers. Tool use seems like a massive focus here. Browsing, Python, even custom functions, that really extends what they can do, doesn't it?
It absolutely does.
Yeah.
This is a huge part of making them practical. They've been post-trained extensively to use tools seamlessly. They have a built-in browsing tool for accessing real-time information from the web, getting around their knowledge cutoff date, which is June 2024.
So they can look things up.
Exactly. And they can execute Python code, not just run a single script, but do it in a stateful Jupyter Notebook environment. That means they can write code, run it, see the output, debug it, and even maintain variables and state across multiple steps. That's crucial for things like data analysis or iterative coding tasks.
Wow, okay.
And maybe the most powerful part is the custom functions. Developers can define their own tools. You just specify the function's purpose and how to call it in the developer message, and the AI can learn to call your specific API, access your internal database, or trigger basically any external action you can code up. This allows for really complex, multi-step agentic workflows. It bridges the gap between the AI's internal knowledge and reasoning and the ability to interact with and affect the real world, or at least the digital world. It's like giving the AI not just a brain, but also hands to interact with external systems. 3. The safety conundrum. Open-weight risks and OpenAI's preparedness.
Okay, let's shift gears a bit. This is where things get maybe a little more complex, potentially thorny for some folks. The sources are surprisingly direct about this. Open-weight models, by their nature, have a different risk profile. Because once they're out there, someone with bad intentions could try to fine-tune them to bypass safety features or even optimize them for harmful uses. How is OpenAI tackling that? It's a big question hanging over powerful open-source AI.
It is, and it's arguably the central question for responsible AI development right now. OpenAI seems very aware of this, and their answer is rooted in their preparedness framework. They state it plainly in the documentation. Once they are released, determined attackers could fine-tune them to bypass safety refusals or directly optimize for harm without the possibility for OpenAI to implement additional mitigations or to revoke access. There's no hiding from that reality.
Right, you can't recall an open model.
Exactly. So instead of just hoping for the best, they proactively conducted extensive adversarial fine-tuning simulations. They basically tried to break their own models, tried to fine-tune them for malicious purposes themselves, using their best techniques to understand just how dangerous they could become before releasing them.
That's thorough. So what did those simulations find, particularly around the really scary stuff, like potential misuse for biological or cyber threats? That's where the biggest concerns often lie.
That was a major focus of the testing. Their independent safety advisory group, the SAG, reviewed all this adversarial testing. Their conclusion, and this is a direct quote from the findings, was that even with robust fine-tuning that leveraged OpenAI's field-leading training stack, gpt-oss-120b did not reach high capability in biological and chemical risk or cyber risk.
Didn't reach high capability. Okay, what does that mean exactly?
Within OpenAI's risk framework, high represents a critical threshold for severe harm potential. So this finding is significant. It suggests that even versions intentionally pushed towards dangerous capabilities didn't cross that specific line for enabling, say, the creation of novel bioweapons or executing highly sophisticated cyber attacks, according to their assessment methods. It provides a baseline measure of assurance against the most catastrophic immediate risks.
Okay, that's somewhat reassuring. Did they also look at whether these models were pushing the frontier of risk in open source? Like, are they more dangerous than what's already out there?
Yes, that was another key question. Are these models introducing a new level of hazard? Their finding was no. They compared GPT-oss-120b, even the adversarially fine-tuned version, against other powerful open models released recently, like Qwen3 Thinking and Kimi K2. What they found was that those existing open models already performed comparably, sometimes even better on certain hazard evaluations than the fine-tuned GPT-oss-120b. So while these new models are very capable, the analysis suggests they aren't setting a fundamentally new, higher bar for hazardous capabilities within the open source ecosystem itself. The risk landscape didn't dramatically shift just because of this release, according to their evils.
Got it. So moving away from those extreme scenarios, how do they stack up on more everyday safety? Things like refusing to generate disallowed content or resisting common jailbreak attempts where users try to trick the AI.
Here, the performance seems pretty solid. On standard benchmarks for disallowed content, fake hate speech, illegal acts, etc., they generally perform on par with OpenAI's own O4 mini model. But interestingly, the sources note they actually, quote, tend to significantly outperform OpenAI O4 mini on the production benchmarks evaluation. These production benchmarks are designed to be tougher, involving multi-turn conversations that mimic real-world interactions more closely. So that suggests good robustness in typical use cases.
And jailbreaks.
They also tested against known jailbreak prompts using a benchmark called strong reject. The gpt-oss model showed similar robustness to a 4 mini here, meaning they were pretty resilient against these common adversarial attacks designed to bypass safety filters.
Okay, so generally robust, but the sources did mention a couple of specific challenges or nuances, right? Something about that instruction hierarchy we talked about, and this idea of hallucinated chains of thought.
Yes, absolutely. Important caveats. Firstly, regarding the instruction hierarchy. While it's a powerful feature, the evaluation found that these GPT-oss models generally underperform OpenAI O4 Mini on our instruction hierarchy evaluations.
Meaning they're easier to trick into ignoring the developer's rules.
Essentially, yes. They're less consistently strong at preventing a user's prompt from overriding a system-level or developer-level instruction. This is a really important point for developers building applications. They need to be aware of this potential weakness and might need additional safeguards, although the docs mention fine-tuning can improve this robustness.
Okay, good to know. And the hallucinated chains of thought.
Right. This is actually a deliberate design choice, which is fascinating. OpenAI intentionally didn't put strong optimization pressure during training to make the chain of thought output perfectly factual or always aligned with safety policies.
Why would they do that?
The stated reason is to allow for external research into code monitoring and interpretability. They wanted to provide a more raw, unfiltered view into the model's reasoning process for researchers to study. But the consequence is that these code tags can contain hallucinated content, including language that does not reflect OpenAI's standard safety policies. So there's a very clear warning to developers. Should not directly show chains of thought to users of their applications without further filtering, moderation, or summarization. You can't just expose that raw thinking process directly.
Okay, so summarizing the safety. Pretty robust against major risks and common attacks, performs well on standard content, but developers absolutely need to be aware of the instruction hierarchy weakness and the need to filter or moderate those raw chain of thought outputs before showing them to users.
Precisely. And one more point, like many smaller open models, they do tend to have higher general hallucination rates on straightforward factual questions compared to larger closed frontier models. So for applications needing high factual accuracy, using the browsing tool to fetch real-time, reliable information is strongly recommended to mitigate this. Don't rely solely on their internal knowledge for facts. 4. Surprising strengths and real-world impact.
All right, let's zoom back out to performance overall. We touched on math and coding being strong, but were there any areas highlighted in the evaluations that were particularly surprising or stood out?
Definitely. Beyond the solid math on A and the impressive coding on benchmarks like Codeforces and SWB Bench, where the 120B model is getting quite close to a 4 mini, the performance that really jumped out was in health applications.
Health. Tell us more. They mentioned Health Bench, I think. What's special there?
Yes. Health Bench, and particularly Health Bench Hard, these aren't simple Q&A. They're benchmarks based on realistic, often complex and nuanced health-related conversations and medical queries. And the results were, well, quite remarkable. GPT-oss-120b especially when using its high reasoning setting, performs competitively to the best closed models, including OpenAI o3. That alone is impressive for an open model.
Wow, competitive with O3.
But here's the kicker. The sources state it outperforms GPT-4o, OpenAI o1, o3 mini, and o4 mini by significant margins on these health benchmarks.
Wait, outperforms GPT-4o and other major OpenAI models on health tasks.
By significant margins, according to their evaluations. Even the smaller GPT-oss-20b model apparently performs slightly better than OpenAI o1, despite being much, much smaller. This was genuinely unexpected and represents a major strength.
That's incredible,
Yeah.
seriously. So you have a smaller, openly available model beating some of the most powerful proprietary models in a critical, sensitive domain like health. What does that actually mean for people, for the potential impact of AI globally?
Well, the way they frame it is as a large Pareto improvement in the health performance cost frontier.
Okay, translate that.
It basically means they've achieved a big leap forward, delivering very high-quality health intelligence and reasoning capabilities at potentially much lower cost and with far greater accessibility than before. Think about the implications, especially for global health. In many parts of the world, access to medical expertise is limited, privacy concerns are high, infrastructure might be lacking, and cost is a huge barrier. While these models absolutely do not replace a medical professional, that's a crucial disclaimer. They could act as powerful tools to bridge gaps.
Like for health literacy or maybe initial information gathering.
Exactly. Think AI-powered tools for health education, maybe support for preliminary diagnosis in remote areas, or just making reliable health information more accessible where traditional resources are scarce. This performance breakthrough could genuinely help democratize access to advanced health knowledge and support.
That's a really powerful potential impact. And speaking of global reach, how do they actually perform across different languages? Is this strength mainly in English, or can they serve a wider audience?
They seem highly competitive multilingually, which is vital if you're talking about global impact. The 120B model at high reasoning gets close to the performance of 4 many highs on the MMLU benchmark across 14 different languages.
MMMLU, that's a tough multi-language test,
Yeah, it
right?
is. It covers various subjects across many languages. So achieving near top-tier performance there suggests strong multilingual capabilities right out of the box. It means these models aren't just powerful for English speakers. They have the potential to be genuinely useful tools for diverse communities worldwide, making that health performance and general accessibility even more significant.
Outro. So let's try and wrap this all up. What does this deep dive tell us? We've unpacked OpenAI's new GPS models, these open weight giants. We've seen how clever innovations like MXFP4 quantization make them incredibly accessible, letting serious AI power run on hardware that's actually attainable. We explored the Harmony chat format, giving developers fine-grained control, saw their impressive reasoning abilities, and highlighted those really surprising strengths in health applications. And importantly, we looked hard at how OpenAI is navigating the complex safety landscape that comes with releasing such capable models openly.
Yeah, I think OpenAI has really laid down a marker here. They've built a foundation. Models designed to be open, adaptable, and, within the constraints of open release, as safe as they could reasonably make them through rigorous testing and clear documentation of limitations. This release really embodies that critical tension, that balance between the immense potential power of these tools and the profound responsibility required for their open deployment. It feels like a significant step in bridging the gap between closed, proprietary AI development and the collaborative, innovative power of the open source community. They haven't just dropped code, they've issued an invitation, really, for the world to build the next chapter of OpenAI, but with eyes wide open to the capabilities and the necessary precautions.
And for you listening to this, for anyone learning about or working with AI, this deep dive really underscores something crucial. As AI gets incredibly powerful, the simultaneous push for transparency, for accessibility, and for robust proactive safety measures becomes absolutely paramount. It's a stark reminder that the tools are getting sharper, more capable every day, and the responsibility to wield them wisely and to continue building those necessary safeguards falls on all of us. So here's a final thought to chew on as you go about your week. If these open weight models, available now to anyone with the right setup, can perform so remarkably well on really complex specialized tasks like advanced coding or even sensitive medical queries, what previously impossible problems could you or your organization start tackling with this kind of accessible power? And flipping that coin, what new, maybe community-driven safeguard or best practices will we need to invent together to ensure this power is used responsibly and for the benefit of everyone? That's all the time we have for this deep dive. Thank you for joining us on the deep dive. Until next time, keep exploring, keep questioning, and keep digging deeper.
欢迎收听豆包 AI 播客节目。
Hello， 大家好，欢迎收听今天的播客。我们今天会聊一聊 Openweight 最新发布的2个语言模型 gpt-oss-120b 和 gpt-oss-20b。我们会从模型的架构、数据的训练、安全测试以及它的应用场景这几个方面来给大家做一个全面的介绍。
好呀，那我们就直接开始吧，看看这2个模型到底有什么特别的地方。
我们先来聊一聊，就是这一次 OpenAI 他们推出这个 gpt-oss-120b 和 gpt-oss-20b， 他们到底是怎么来定位这2个模型的？然后他们在安全性上面是怎么去考量的？
这2个模型它其实是基于开源社区的反馈，然后来开发的2个文本生成的模型，它是遵循 Apache 2.0 许可证的，同时它也是适配我们的 Response API 的。对，它的特点的话就是支持工具使用，也支持推理，也支持自定义。对，它特别强调的，它是在安全的这个基础之上去做的这样的一个设计。
听起来确实挺强大的。然后呢，他们在安全上面具体做了哪些事情呢？
他们就是做了很多评估，然后包括说对抗性的微调来测试它在比如说生物化学和网络安全这方面的风险，这些都经过了他们的这个安全顾问团的一个审查，结论都是说没有达到高风险的这个阈值。对，同时呢，他们也发现就是说，现在目前已有的一些开源的模型，在性能上面已经和这些经过对抗性微调的模型很接近了，所以他们觉得就是说，也没有必要再去进一步的推高这个技术的上限。
那这2个新的模型，它的架构上面、数据的使用上面、训练的过程当中和评估的时候有什么亮点呢？
它是一个自回归的混合专家模型，然后它是基于 GPT-2 和 GPT-3 的架构。他们这次发布了2个尺寸，一个是120个10亿参数的，一个是20个10亿参数的。它的这个模型的设计也是特别考虑了推理的效率和内存的使用。对，在数据方面的话，他们用了上万亿的 tokens， 这些 tens 呢是特别强调了 STM 和编码，也做了一些对于有害内容的过滤。
听起来在各个方面都挺讲究的。
对，
然后呢，训练和评估还有什么特别的吗？
训练的话，他们是用了 NVIDIA 的 H100 的 GPU， 然后用了 PyTorch 和 Triton 来进行优化。120个10亿参数的那个模型训练了相当于210万个 H100 的小时。在评估的时候呢，他们是在很多的基准测试上面都跑了，包括推理、编码、工具使用，在这些基准测试上面都表现出了非常有竞争力的结果，尤其是在数学推理上面。
那在安全测试和缓解策略上面 ，OpenAI 对于这2个新的模型做了哪些事情来确保它们是安全的呢？
他们就是使用了一种叫做 deliberative alignment 的方法，来让模型学会拒绝不合法的内容，然后同时呢，也让它对于这种越狱攻击更加的鲁棒，也确保它能够遵循指令的优先级。
听起来确实挺严谨的。然后呢，还有什么其他的吗？
他们还做了就是对于这2个模型在生物化学和网络安全上面的风险做了评估，然后结论是说这2个模型都没有达到高风险的这个阈值。对，他们同时也强调了就是说这种评估其实也反映了这些模型在被下游的人去修改之后可能会产生的风险的范围。对，所以就是说既能够让大家去使用这个模型的开放性，同时呢又能够防范可能会出现的一些恶意的使用。
在默认的安全性能上面，这2个新的模型遇到了哪些挑战？然后评估下来是什么样的结果呢？
他们就是在做评估的时候发现，就是说传统的这种对于不合法内容的测试已经没有办法体现出他们的这个安全上面的进步了，所以他们专门设计了一套新的生产环境的基准测试，然后他们未来可能会停止使用 旧的这些评估方法。
好的，那今天我们跟大家聊了这2个新的模型，它的强大的功能，它在架构上面的一些创新，然后以及它在安全上面非常严谨的一些设计。相信大家对于这2个新的模型有了一个全面的了解。
OK 了，以上就是这期播客的全部内容啦，然后咱们下期再见吧，拜拜，
拜拜。